Hello, I'm Arthur. Welcome to my lab. One of my viewers was curious about what this blue device is, this blue box. So I have a set of batteries here connected to my mini power supply. This is just a voltage regulator that outputs 3.3 volt. I use it to power my test circuits, and this powers this blue box. And what you can do with it, well, pretty much whatever you want, because this is a programmable device that you can just program to do whatever you want. So right now it's programmed to output the pulses that RC controlled hobby RC model devices use to control various things. I was using it to control this electronic speed controller, ESC, which then can be used to drive hobby motors. So I was playing with a motor, and I was using this as a pulse generator to generate certain type of pulse to control that ESC. So what's inside of it? This is my rotary encoder and my display. Here I have 4 LEDs. This is a 4 LED version, a newer version. This one is an older version with only 2 LEDs. And on the other side, we have some passives, the 2 MOSFET transistors to enable the digits of the display because it's being multiplexed, and a CPLD, Altera Max 5 series CPLD. CPLD stands for Complex Programmable Logic Device, and basically what it is just a bunch of gates, and you write the program that describes how these gates get connected. So with that, you can pretty much do whatever you want. If you want to have a counter that divides the input frequency, because one thing that I didn't mention actually is underneath there's a crystal oscillator. So if you want to divide your oscillator's frequency that's being delivered to this device, you just chain a bunch of gates together into a divider, frequency divider. Then you can send that divided frequency, which is lower than your input frequency, to a counter that counts certain length of time. Then you can have another counter which counts those time ticks and outputs pulses based on those counts, and so on, so on. That's a long story. Basically, you can do a lot of different things, and the difference between this and a microcontroller is that microcontroller really does only one thing at a time. It does it so quickly that it may appear like it's doing multiple things at the same time, but really any microcontroller only does one thing at a time. And this CPLD can do a lot of things at the same time, because you can parallelize multiple blocks doing different functions and have those blocks run at the same time. So CPLDs and more advanced chips called FPGAs are really fun to play with, and you can create a lot of different projects and a lot of different devices using these things. Here's a test board with another Altera chip. This is an FPGA. So I was testing something with a bigger display here. So I really love playing with CPLDs, and I'm going to get into this at some point in my videos. I'll demonstrate some of my test boards and explain how you can get into this. And this is the PCB for this device here. This one is probably not the best starting point for somebody who doesn't feel comfortable soldering these fine pitch chips. Let's see. I probably won't be able to get this in focus from too close, but this is a really fine pitch chip. Here you can see the individual pins. So this is the PCB for it. And again, probably not the best starting point for somebody just getting into it, but if you feel comfortable soldering fine pitch SMD, then by all means you could try building a device like this and experiment with it. But I'll have some simpler boards that I can demonstrate that can be used as a starting point. In fact, let me grab one and show it to you. So here's another test board for a CPLD. Again, an Altera part, a much older one. This is really old school. This is a 5-volt device, and this PCB is much simpler, although I still have some SMD mounted components, but this is mostly through the hole soldering, so much easier to assemble. Just a few SMD components, a removable crystal here, so you can use different sources of clock, different sources of frequency. And again, you can program this thing to do various things, whatever you feel like doing when experimenting, or using it for some specific task. The first thing that I usually do is I program this Hello World for programmable devices, and I hope I'll get the polarity here right. There we go. No, apparently I programmed something else into this one. I just grabbed a random board that I had sitting in my bin, and it's not doing my Hello World pattern. But as you can see, you can use these pins to connect some outputs, inputs, and do stuff with this one. So this would be a easy starting point PCB, where you use this old school Altera device, and all you need to program these is this Altera USB blaster, which you can buy on eBay for about $10, and free software from Altera, or currently Intel bought Altera, so free software from Intel that allows you to program these. But if you're going to experiment with these very old, I believe this is Max 7000 series, yes. So if you're going to play with these very old chips, then you're going to need an older version of Altera software, because in newer versions these chips are no longer supported. And another board that I designed, which is a little bit simpler to assemble because the pins are a little bit bigger here, is this board for Lattice CPLD. And again, you can get free software from Lattice, but I really don't like that software as much as I like Altera, because it's a lot more cumbersome to use and less featureful compared to Altera. Altera software is really great. Another leader is Xilinx. They also have great piece of software. I tried both, and I've played with both chips, but I feel more comfortable. I like the features of Altera software much better, so that's my main vendor. But I started playing with Lattice because, for several reasons. They still have chips in this package where Altera is moving away from it, and they are making it more difficult for hobbyists like me to play with these devices, because the packages are becoming mostly BGA or only BGA, and that's just pretty much impossible to solder in amateur conditions. So these packages are actually, even though they look scary at first, they're fairly easy to work with. You just need a hot air soldering station. That's a must. But once you have that, you're good to go. These are fairly easy to work with. But again, Lattice software, not as nice to play with as Altera. So for starters, I recommend definitely going with Altera, and then if you want to, you can also switch to Lattice. So this board is a little bit easier to assemble, and again, usually I have some sort of test circuit. I haven't played with this one in a while, and I don't remember how I've designed here. I haven't labeled the polarity of the input voltage. Here we go. Now it's plugged in. Let me see if I have some pulses here. There we go. So this is my test pattern. Usually this is my hello world, where I have a light glowing for each pin, and then I can make sure that I haven't shorted any pins, that they are all connected. I just have this glow pattern going across. And for lattice, again, you can buy programming dongle on eBay. Those are a little bit more expensive. I think I paid for mine about 30 bucks, but not horribly expensive, so you can still get into that and play with lattice chips. So that's another board that might be good as starting point. And here's actually a little more advanced board where I wanted to start playing with QFN chips, which are really tricky to solder. They don't have any pins, they just have these pads on the bottom, and so you have to work on your technique to be able to work with these chips. But this is another lattice chip. This actually has more capacity as far as number of gates compared to this, and it's just a fraction of the size of this other chip. So eventually I will probably record a video talking about this board and this chip, and we'll get into that trickier stuff. But for now, we'll get started with boards like this that are much simpler to assemble. So that's it for today. That's it. That's all about this Magic Blue Box. Hope you enjoyed. If you did, please give me a thumbs up, subscribe to get notified about new videos. Talk to you later.